G'day everyone, I hope all is well. So today we're going to look at part 2 of my sim wheel build. It's a 3D printed DIY Bluetooth button box that connects via Ultimark BlueHID BlueHID controller. This board has been used previously by a few others, but it definitely hasn't gained as much traction in the community as I would have thought, especially considering it's been around for a while now and has a pretty impressive feature set. Some of those features include ultra low power sleep mode and built-in battery charging circuit. This allows the board to charge the connected single cell battery via the USB cable. That's pretty nifty. Okay, the first thing you want to do is make the top face of the button box a little nicer. I just got some really cheap carbon fiber vinyl wrap. I don't even think it's the proper wrap, I think it's just a carbon fiber sticker, to be honest. Pull the sticky back. The easiest way I found to do this is to work from one side to the other, slowly going with a store card or credit card and just pushing out the air bubbles as you go. You could try getting something cylinder shaped and roll it along as you move, but the card works fine. Next, you want to get a Stanley knife or box cutter and cut around the outside of the 3D printed part. And try to get as close to the edge as you can so you get a nice clean finish. Once you've got your holes all cut out, go ahead and start installing your buttons. The buttons come with a nut to go behind the button to hold it in place, but I found that being more cumbersome and actually just harder to work with. Luckily the 3D printed piece was the correct size for the buttons thread and they screwed in really nice and tight, and I don't have any worries that they'll come loose. The encoders do the same. I screwed them in and the nut goes on the other side and holds them tight, so they have no chance of coming off. Next, I got the spacer ring up. I just wanted to dummy fit everything up to make sure it's all going to fit. I put the spacer ring inside the casing. I then figured out how I'm going to go about the BlueHID installation. I was hoping to not have to cut anything out, but I think I'm going to have to cut the bottom of the spacer out and just have 5 bolts instead of 6 securing the wheel. 5 bolts is plenty, I think, for securing a wheel. I'm more than happy with 5 bolts. I also want to try to get the USB extension cable I bought, which is a male to female short length, and I want to mount it down the bottom somewhere so I can just plug a USB in to charge it up whenever I need. Okay, so the BlueHID is separated into J1, J2, J3, J4 junction blocks. Each block has its common ground, which is a single pin by itself. Then you basically put your signal pins, so you daisy chain your ground to your switches, and then run the other side of the switch to your signal pins. As for the rotary encoders, you got your push button on one side, then you've got your common ground in the middle on the encoder side, plus your 2 signals. Now, only this J4 can do quadrature, which is what you're going to be needing to set up for the rotary encoders. So you'll have your ground daisy chained to all four. Then you'll have your two signal pins running to two pins here, and then you'll set that up in the configuration tool, so you'll basically max out this whole block with your encoders, and then you'll have to link the switches in series to one of these blocks over here. So first we'll start bunching up groups of buttons. So we're going to be doing 1, 2, 3, 4, yeah, groups of 4 probably, and using these 3 blocks for the switches. Okay, so now we want to get on to soldering up the button box. I find the first thing to do would be to tin all the connections inside, all the buttons. So I just run the soldering iron with some solder over each connection. It just makes life a little easier when soldering the wires later on. Just remember, use flux wherever you can. Flux everything. Flux is life. Now, what I did here is I cut all my wires to length. I daisy chained them up. This is for my negatives. I then went ahead and just soldered them to each of the pin. Made for a lot of easy work rather than soldering each wire individually and then them coming loose every time you want to add the next wire. Yeah, so I found this is a very effective way of doing the wiring. Once you've got all your negative earth wires connected, I went ahead and cut a whole bunch of the positive wires, or the switching wires that will go to the BlueHID, and just solder them to the other side of the buttons. And do this for every single button, even the buttons on the encoder. Okay, with the BlueHID, you've got 4 junction boxes, groups, or whatever you want to call them. Each one has a common ground, like so, and then your inputs to the other pins. To use the encoders, rotary encoders, you have to have obviously common ground
and then 2 signals for each encoder up and down. So that'll take a whole block. Only J1 can do quadrature, however you say it. And then we'll do 8 buttons on this one and 8 buttons on this one. But I was going to use a pin header similar to this, but we've got height restrictions here, so I might have to solder to the pads here, or I might try soldering to the pins. We'll see how we go.
Soldering to the underneath of the board proved to be a little more difficult than anticipated, so I ended up flipping it over and soldering onto the pins themselves. Soldering to the pins isn't quite as difficult as it looks. It's probably just a bit more annoying with having all the wires and getting tangled up more than anything. I got this nice board holder. It holds lots of other little things too, but I find it pretty handy. It's probably the best $10 I spent back in the day. Now for the shifter assembly. First thing you want to do is check fitment. Make sure everything's nice and not snug. You want it to be able to move freely. Get the drill out all the holes. Make sure everything's ready to go. If you've got some tight spots, use a file the insides and the sides of the lever arm. And once you've got a nice smooth action, then you're ready to assemble. Next, I find easiest thing to do is press in all the M3 nuts. I use a pair of multi-grips, so I find that nice easy way to press things in. Just be careful when you're doing it that you're not grabbing on something that is fragile and can break. Then we want to super glue the magnets into place. I find this is a little tight. Make sure you use something non-metallic when pressing the magnet in, otherwise you'll have a hard time. It'll stick to the metal end and pull it out. It's a pain in the ass. Then work on installing the micro switches. Now there's 2 spots for these. I don't think there's any right one to use. I just picked one and had to file it out to size. Once I've filed it out enough, I got a nice pressed fit in there. You can probably hot glue it if you want, but I don't think mine's going anywhere. It's a pretty tight fit. Then you want to solder your wires, so your ground to ground and your activating wire, you want it to go to normally open circuit. Now we want to bolt the lever arm up, screw the screw in. I found the design was a little lacking here, as when you put the nut on the other side of the screw, it actually doesn't sit flush with the side of the body. It connects on the little extruded part, so it's a little annoying, but you don't need this bit to be tight anyway, because if you tighten it up, it's actually going to stop the lever from springing back to the magnet. It will keep it too tight. So later on in the video you'll see I just dabbed a little bit of hot glue on the end to stop it from unscrewing. You could probably just put a second nut if you wanted to and lock nut it. And make sure when you're pulling the lever that the switch is getting activated. You should be able to hear it click, and make sure the actual magnet's pulling the arm back as well. If it's not pulling it back, you might have to push the magnet through on the base a little more to get a stronger pull, but I didn't have any problems with this, so I think it's designed to just work. So when bolting up your shifters, if you haven't already cut out the holes, cut them out. I just cut a couple crosses and force the screws through. Next, you want to solder your two earths from the shifters onto the BlueHID board and your two activating wires to an available pin slot. Okay, so in order to power this, we want to I've got a mini USB which plugs into your BlueHID, and then I've got a micro USB female, and that's gonna slot in this hole here, and then I'm going to connect it, and that's going to supply the power. Okay, next you want to get your wheel, put the bolts through, pick up the button box that should align the spacer and the button box to the wheel. Then you want to look at putting your backing plate on. Remove one of the levers to help you get the backing plate on, otherwise you'll have no chance. Once the backing plate's on, make sure all your wiring is out of the way of the pickup holes where you're going to screw the backing plate down. I found that the battery wasn't going to fit inside, but it was going to fit inside this spacer on the rear, so I ended up just laying it in the spacer and hot gluing it in place so it doesn't rattle around. For now, not the best solution, but SilentChill has actually modified a adapter. It will go between the button box and the quick release, and it's actually a housing for the BlueHID. So in the future, when I get some longer bolts, I'll look at installing that, and that'll get the BlueHID out of the box itself and into its own little encasing. I didn't use this initially because I was going to use a quick release and it was going to make my whole wheel setup too long, but now I've got rid of the mechanical quick release and I'm just using this 3D printed one. I've actually gained some extra leeway to install the box, so in the future I'll install that, and that'll be a little nicer. Next, once you get your spacer, you want to just put your quick release adapter on, screw that down, screw everything tight. For the making of the video, I only had 3 bolts long enough available locally, so until some more come, that's all I've got holding it together. But it gives you a good idea of how this button box works, and overall I'm stoked. So let's get on to programming the board. First thing you want to do is go to the BlueHID website, which is u-hid.com. This is the Ultimark website. You can click on download. It'll take you to this page here. Then you've got your technical manual for your BlueHID, and then you've got your uconfig installer. You want to download this installer because this is what we're going to be doing to set all our buttons and attributes up for the board. So download that, install that. Now my board came with version 1.13 or something firmware, and I think 1.5 is out now, so you can download the firmware here. And if you're lower than 1.3, then there's a special procedure you have to follow. It's kind of annoying, so I can run you through that now quickly and just explain some things you gotta look out for. Okay, so in the procedure it says basically you have to remove your Bluetooth adapter, right? So you go to your device manager, you right click, you go to uninstall device. Don't remove the drivers when it asks you to, just uninstall it, keep the drivers there. Then make sure you unpair it with the HID BlueHID. Now once you've unpaired it and you've removed your drivers, you can go action scan for hardware changes, and that will basically find your BlueHID again, and then you connect to it, and it says when you're in the actual uconfig utility, right, you'll go to firmware upgrade. And okay, anyway, so once you've done that, it's going to come up in your Bluetooth menu as a Ultimark loader, not Ultimark BlueHID. So what it wants you to do is first scan your system for new hardware. It'll find all your Bluetooth stuff again. Then plug in your BlueHID. Connect to the Ultimark BlueHID. Once you've actually connected, you literally have 30 seconds to quickly open the UHID config utility. You have to connect before you open it, otherwise it won't find the board. Then you have to go to File, Firmware Upgrade, click OK, and then what it's going to do, it's going to put your BlueHID into like a loader, but you've only got very short time to do this. And what I found is the loader, you have to go scan for new devices again. Once the loader is visible, you can't actually connect to it if you're still connected to your BlueHID. So what I found you had to do is go back here, click on your BlueHID, remove it, or unpair it, sorry, and then quickly connect to your loader. Once you're connected to the loader, then it'll go into the firmware update utility. Now the firmware update utility looks like this. And once here, you click rescan, nothing happens. It's like it doesn't do anything. You see that the loader's connected in the Bluetooth utility, but it's still not working here. Took me a while to figure this out. I actually closed this down and I ran the blue, wherever it is, what I just ran there, the blue upload.exe in the installation folder. And as soon as I opened it again, it found it. And away I went, I uploaded the firmware. I went load firmware, found the firmware, and click program. So it's a bit of a pain in the ass, and it took me like an hour and a half to finally get it to go. And you're all under a time, because apparently what happens is when it gets the Bluetooth keys or something, it stores them on the computer and you can't actually connect to the loader again. So you have to uninstall your Bluetooth card, and that removes all the keys. So when you're actually connecting to it for the first time, it sets all its Bluetooth keys up, and that takes about 30 seconds. So you've got to do all this within a short period of time. Anyway, good luck with that. Otherwise, you might not need to update it. You might be fine. You probably don't need the updated features. I'm not even sure what it adds. So I just usually try to run the latest firmware and everything when I get it, and just to start it up. Now it's found my board's available one. So you'll plug your board in via USB just to get some power to it. Mine's running off the battery at the moment because it's in my wheel. But you'll have all these will all be grayed out, pretty much waiting for you to program them. This is currently how my board's programmed at the moment. So you've got this J1 header is all set to my encoders, my rotary encoders, and each up and down movement is the top and bottom. So you got these two here is one encoder, these two here are another encoder, and so on. So the way I did this is you click on the top first pin, I went to quadrature, I click the button pair, so 1, 2, it automatically sets these two up. All right, and you're good. You click on the next one, it'll ask you to save or apply it. Yes, no worries. And this one, 3 and 4 buttons, same as this, 5 and 6, 7 and 8, and so on. That's your earth for that J1. Now the next one, basically, I just went through and started from button 9 because this was button 8 it finished on. So I went through all these, button 9, button 10, and then what I did is, it's just a switch, it's a gamepad, you choose your button you want. Now, the down action would be normal primary, so that's pressing the button. And the up action is clear that action, so that'll be releasing the button. All right, so you do that for every single one, just going from up 9, 10 upwards. What I did find was there's a couple, button 13. Now this button 13, it's looks like it's a shift key as well. Now this pin is pretty laggy. So for some reason, if I push the button that's attached to that pin, it's probably half a second delay. Everything else is pretty much instant. Like you won't even know that it's Bluetooth. It's pretty impressive. I'm really happy with it. Now, so I'd probably avoid that pin. I just don't want to have to pull it apart and desolder that pin. Another pin I had issue with was I think it was pin 9, one of these two. Now, it just didn't work. I don't know why. I basically just removed that pin, that wire, and I soldered it to a pin over here, and it works. So yeah, I'm okay with that. That works. I'm happy. So just be careful when you're checking all your buttons. If they're not working, make sure you got good connections to everything first. And it might just be a dead pin or something. I'm not too sure. So if you get a pin that's not working, it's probably not the button that's broken. It's more or less maybe just the same issue here. Just reallocate it to another pin and it should be fine. If not, then yeah, check the button, replace the button, see if that helps. So once you've got all your pins set up, then you can go and you apply it all. It should all just save, no dramas. Right, we can close that. And what we want to do is you go to Windows, type in game, hit enter. Now this is all your game controllers. So it's a 6-axis 32 button joystick with a hat switch. That's what it's called. Click on properties. Now this is where you can test all your buttons. Once your buttons are up, so you press all the buttons, there we go, they're all working. Check everything. The only issue I have with it is the encoders. I know SilentChill, Craig, he's also built this wheel and with the BlueHID, and we're having issues with the encoders. They sort of double press, so you might, if you rotate them too fast in a certain direction, they might sometimes, yeah, flick the down by accident. But I think the more I've actually used mine, they're getting a bit better, and I find if you go slower, they do sort of activate a bit more precise without giving you false button presses. So I think they're getting better. I think maybe they just need to be worn in a bit, or yeah, who knows, maybe the firmware update actually did something, because I did notice they were a little better after the firmware update, but that could just be, it could be anything. So in the future I might try to get some different encoders, maybe some sort of less clicks per revolution. Maybe these are like 20 clicks I think, or per revolution, which maybe is too close, and it's maybe if you have 10 per revolution, for instance, it might less chance for it to give you false positives. So anyway, but I find that it's working enough for me to use it in game, so I'm okay for now. But in the future, if I build another one, I'll probably try mess around with some different encoders. All the buttons, yeah, work good. So if you got everything working, if you're happy with everything, then you can basically go into your game and start assigning everything. So you'll basically, it's real simple. You'll load up your game. So I set a cursor, for instance, here. We'll go to settings. Click on what you want. So next gear up, then you pull your paddle. And you click on the previous gear, pull your down paddle, and it'll just recognize it. Very easy. Go set up your up and down button, encoders to whatever you want, basically. Come down, you can set all your headlights and everything up, your views, and then save your preset. Every game's pretty similar to this, so you'll figure it out. It's pretty straightforward because Windows has registered it as a joystick, so it should work with every game without problems. So yeah, that's pretty much it as far as setting it up goes. It's very simple. The USB charges it in about, I don't know, an hour and a half, 2 hours. It's pretty quick, and it lasts for a few days really. I haven't got a switch set up on it, which I probably should have put a switch so I could just turn it off, but when I'm not using it. But it does go to sleep mode, and it uses like 0.03 milliamps or something really low powered, and it would probably just sit there in sleep mode for weeks without sort of going flat. It's pretty impressive. Alright, that's all we have time for today. If you like this video and you want to see more of this stuff, like and subscribe. If you got any questions, leave a comment below and I'll try to help in any way possible. Anyway, I'll see you on the next one. Catch ya.